Good morning and welcome to a video on synthetic division. So let's talk about the uses of synthetic division and when it's helpful. Let's say I had a polynomial f of x and that was equal to x to the third plus 5x squared plus 2x minus 8. Okay, and let's say that we know that x plus 4 is a factor, okay, of the polynomial. So what does it mean to be a factor? It means that x plus 4 divides evenly into the above polynomial. So just to make common sense out of this, right, if I said 6 is a factor of 24, right? That just means that 6 divides evenly into 24 with no remainder. So it's the same thing with algebra, just a little fancier. So I know x plus 4 is a factor. And so what I want to do is, since I know it's a factor, I know it divides evenly into the polynomial, when you divide, you want to see what's left over, right? So let's see if I can divide and find maybe other factors. And let's see if I can factor this polynomial using synthetic division. So if we know that x plus 4 is a factor, right, then we also know that x equals negative 4 is a root. And what we do is we put the root outside of this little box, okay, and we put the coefficients of the polynomial, 1, 5, 2, negative 8. And we're going to get, hopefully, if we did this right, a 0 remainder. And the quadratic that's left over will be another factor, okay? Just remember, if I was missing any of the x terms in succession, I'd have to put a 0 in. So let's bring down the 1. Negative 4 times 1 is negative 4. I'm going to add 5 and negative 4. That's 1. Multiply negative 4 times 1 is negative 4. I'm going to add these two together. That gives me negative 2. Negative 4 times negative 2 is positive 8. Adding together is 0. Okay, so the fact that I got a remainder of 0 means that x plus 4 was a factor, just like I thought. And then it means that these three numbers are the coefficients of my quadratic. Now, think about it. If I start with a degree 3 and I divide by a linear factor, that means I'm left with degree 2, right? So if I had, just real quick, like x cubed over x to the first, right? That's like x times x times x over 1x. That leaves me with x squared, right? So that means the numbers are going to form a quadratic. So this, now I know this is x squared plus x minus 2. Okay. So at the end of the day, what I know is that the above polynomial factors as x plus 4 times the quantity x squared plus x minus 2. And let's see if we can factor this even more, right? We can, right? So x plus 4, this trinomial factors into x plus 2 times x minus 1. So I have efficiently and completely factored my original polynomial, knowing that I had one factor, and here we go, right? Now I could graph it, I could find all the x-intercepts, the y-intercept, and if we think about it, if we didn't know that x plus 4 was a factor, at some point, if we use the rational root theorem, we would have put x plus 4 is a possible factor, right? Because 4 is a factor of negative 8. So we would have gotten to it eventually, but it was helpful to know that this was a factor. So I hope that helped a little bit. That's an important use of synthetic division. It can really help you factor polynomials and find other possible roots.